An airplane has an airspeed of 500 kilometers per hour at a bearing of north 45 degrees east. The wind velocity is 60 kilometers per hour in the direction north 30 degrees west. Find the resultant vector representing the path of the plane relative to the ground. What is the ground speed of the plane and its direction? So let's go ahead first and measure off from north and go 45 degrees east. And so this is 45. This would be what the airplane is doing, and its magnitude is 500. Now let's do the wind. And so the wind is north 30 degrees west, so over here to the west 30 degrees, and the magnitude of the wind is 60. So let's go ahead and take that and put that vector up here on the tip of the other one. And so this was 60 here. And let's draw the resultant vector. The resultant vector then would be here. So this is our resultant. And this was our airplane. And this other one here was our wind. Okay, so what I'm going to do is I'm going to express each vector in its component form, the airplane and the wind, and then I'll add those together to get the resultant vector. So first of all, the airplane, as I look, it was 45 here, but that means it's also 45 there. So its angle is 45, and so we've got 500 cosine of 45 degrees for the x component and 500 sine of 45 degrees for the y component. Now let's go ahead and express the wind. Now looking at our wind vector, which was the green one here, let's go ahead and measure off from 0 this angle, and we know if this was 30 here that it's 30 degrees up there as well, plus this 90, so that complete angle is the 90 and 30, or 120 degrees. And its magnitude was 60, so we got 60 cosine 120 degrees and 60 sine 120 degrees. So now our resultant vector will be the sum of those two, so we add the x components together. So the first one's 500. I'm going to go ahead and sub in the cosine of 45, which is square root 2 over 2, and then add to that 60, and then we need the cosine of 120, and the cosine of 120 is going to be, let's think about this on the unit circle, 120 is 30 past 90, so it's right here, so it's going to be negative 1/2 for the x value. All right, and then we're going to have 500, and we've got the sine of 45, which is square root 2 over 2. We're going to add to that 60, and then we need the sine of 120, which is square root 3 over 2. Okay, I'm almost off the edge, but I think we got it there. So that is our resultant vector. We could put those values in the calculator to get a decimal approximate, and I think I'm going to do that so that we could then compute the things that we need to know. So if I do 500 square roots of 2 over 2 plus negative 30, it looks like there, I get 323.5534. We'll go to 4 decimal places. And then 500 square roots of 2 plus 30 square roots of 3. 500 square roots of 2 over 2, or 250 square roots of 2 plus 30 square roots of 3. And a decimal approximate for that is 405.515, because it's going to be 497 and round up. So there is our resultant vector. Now the things we want to know is, first of all, what is the ground speed of the plane? So that would be the magnitude of this resultant vector. So it's going to be the square root of this one squared plus this one squared. All right, so when we compute that in the calculator, square root of 323.5534 squared plus 405.515 squared, that is going to be 518 to 1 decimal place 8 units or miles per hour. Now we are ready to find out this angle for the resultant vector. And so that angle is going to be tan inverse of our y value, which was the 405.515, over our x value, which was the 323.5534. And it looks like we get, to 1 decimal place, 51.4 degrees. Now that's actually, I shouldn't have circled that. That's not our answer, because that would be this angle. Let's come up to our picture. I kind of got too many things on the picture. Let me see if I can erase some of that so we can see this a little bit better. All right, so that angle we found was this angle right here, up to the resultant vector was 51.4, but if we want to give it as a bearing, we want to measure off from north, so we want this angle right here. Well, we can see that those angles are complementary. Their sum would be 90, so if I want to list this as the bearing for the direction that the plane will actually head in relationship to the ground, it's going to be north, and we do 90 degrees minus this 51.4 and get 38.6 degrees east.